Hey guys, welcome back. I wanted to just introduce a new project I'm working on. So as you can see, it's a new folding knife. Unfortunately, around Christmas, I lost the folding knife I made in this channel, the series on making a folding knife. I've been carrying that knife since that I made that video series, and it was great. Um, there was some issues with the lockup. I think I mentioned that in the original videos that my um, lockup wasn't perfect, and there was several helpful comments on those videos giving me some advice on the angle of the lockup and stuff. And I intended to take apart that knife at some point and fix it. Um, Unfortunately, I never got around to it, and then I lost the knife. But here is the a 3D model of a new knife. It's a little different than the last one. I tried to go for a little sleeker, thinner design. So I really like a fine tip, just something I've been learning. I also trust myself not to use it as a screwdriver, or if I do, it's my knife. If I break it, whatever. I'd prefer to have it there. The blade will be out of a piece of 440C. I got some stock from the last folding knife. The handles are going to be out of titanium. I got a sheet of 1/8 inch titanium off eBay for not much. So hopefully I can fail a couple times on making these handles and still have some left over. Um, these will probably be out of some stainless steel, or I think I might have some 1/4 inch titanium still that I can make them out of. This is the pivot design I came up with. Let's try hiding this. So I have this triangular hole in here because well, for one, I'm going to try to make these handles at least on the on a CNC Haws. That's why they also have this nice 3D contour shape, and it makes it easy to do little pockets like this, where this kind of pocket would be very difficult to do on a manual machine. Um, to do it on my manual mill, a square is easier, obviously 90 degrees. Um, but I kind of like this triangular shape because it looks cool and it kind of shows to people who understand it, it shows that it was not as easy as just cutting a square. Um, this counter bore, very shallow counter bore, is also a difficult thing to do because you'd have to get an end mill that's, you have to do, what is this? Yeah, it's like almost a 5/8 end mill and like cut it perfectly. So in my CNC toolpath, I'm not sure if this is the best way to do HSM Works and CAM in SolidWorks, but I have a different assembly with my handles laid down, and copies of them on jigs and stuff. So I have the 2D contour to cut out that pocket somewhere here. Yeah, so just a pocketing operation to cut out this counter bore and a couple 2D contours to cut out this triangle and stuff. I'll go through all this in a minute, but I want to go back to the assembly. So I also have this nice curve on this lock bar cutout because I think that looks kind of nice. It kind of goes with the flowy curviness of these handles. I have just round studs that locate and hold the spacers, I guess. As you can see, they have a little locating feature that will fit into the holes on the handles. They're once again pretty easy parts to make on a manual machine. One other thing I did is a lock bar stabilizer. I think that's might be what John Grimsmo calls them. This is kind of my idea on how to make one. So yeah, all this design philosophy basically just comes from watching John Grimsmo videos and seeing how he makes his knives and then trying to design them in a way that I can make them with far less advanced machinery. Some of his really early knife making Tuesdays were helpful, and he was where I learned a lot of it because that's when he's using machinery like I have. But this was my idea for it. So this is just a 3/32 pin that I will drill a hole in here, obviously, which is kind of an impossible to make feature. But the idea is this will be bent. This will be bent out in normal operation anyway. So I can just bend that out, clamp it in, drill a little hole, press in the pin, and then this groove can obviously be cut. I believe I'm going to cut this with just a 16th end mill, so it'll be wider than this. This groove, that doesn't really matter. It just needs to be set into the handle so that the blade, as it rotates around, doesn't hit it. I like this system because it doesn't involve making a screw with a giant head or anything like that. I'm also doing, I'm not sure exactly what to call this, kind of an inside groove stop pin instead of a stop pin that's not really a groove, it's just a kind of a bump here and a bump down here, which is how I've done all my other knives. I'll show a picture of that. I think I still have the model of the old folding knife. Down here, having to have kind of the open groove means that you end up with kind of a sharp edge right here. And on my old folding knife, as you closed it, you could easily kind of chop a chunk out of your finger because this came down at kind of an angle here, leaving a pretty sharp edge, and as you closed it, it caused a pinch point about here. This way, none of that, the whole blade's smooth. I like the design. It makes it kind of cool looking if someone is to take it apart, and as a geek, I like it that way. And I didn't want to make the same knife again. I wanted to mess with new design elements and stuff like that, because I'm still trying to learn knife making, obviously. I'm nowhere near an expert, and I just enjoy trying different design elements, seeing which ones work. Maybe this will completely fail and be really difficult to do, so I won't do it next time. I'll figure something else out. But I want to try it because it is a pretty elegant solution. Same with this groove and this triangular shape on the back of the pivot to keep it from rotating. That might be way more work than it's worth, and it might just be worth having a little flat, like a kind of a D shape. Here you can see these are just screws I downloaded from McMaster-Carr, which means they're the same model. They're exactly the same as the ones I can buy. Pretty simple, just counterbore. It's a 632 screw. It makes it a little bigger, which I kind of thought looked nice here, and it gives more strength. But I could probably use any screw for that. I just the head size was the correct aspect ratio basically for this side of the knife. If I'd used one of these 080 screws, it would have looked kind of stupid. The 440 screws I still thought were a little bit too small for this head shape, and it's a tap size I have. I don't have any 5 or 3s or 2 taps. So yeah, these are 080 screws because once again I thought the just the ratio of the heads looked the best for these in these corners. Anything bigger obviously wouldn't work down here, and I wanted it to be centered on this fillet here. And I like the way this knife flows, and hopefully it'll fit my hand well. I'm not finalized on this, obviously. I'm still thinking it through, but hopefully it'll work out. So first thing off, I'm making this jig, which, let's go through and hide some stuff. It isn't as simple as it is just a block with some holes, tapped holes in it, because it has these 2 studs, which are 3/16 in diameter, and they'll be machined. I could probably press pins in there, but I have to face this part anyway, so this was an easy operation to do. And simple facing operation to get down just the top of the material, then a horizontal. I had a 2D adaptive to come in and do that, but it really didn't seem necessary because these are only, what are they? They're only 35 thou tall, so that's basically stock to leave in a adaptive operation. So it was just worth just doing horizontal. Saves time. Just spot drilling all these holes and then drilling them. I could add a tapping operation. I don't really trust a rigid tapping operation for a 080 tap, so I'll just do those by hand. I have all these holes because, as you can see, let's show these handles again. Once these are flipped over, I have holes in the correct position to hold them on their backside and their front side. That's why I have these, it's copied over. So yeah, let's go through the manufacturing. So once I have the jig, of course, then I'll have the handles set up on it. But first off, I have to drill the locating holes to fit on the fixture and screw down. So here's my stock. It's kind of rough, roughly the size of the stock I'll cut out. So this operation I will do not on the jig. So this won't be here. This will just be mounted down onto a plate or something like that, scrap piece of aluminum. And I'll go through, and these are just center drilling for these holes and this hole. Then through drilling all these holes, which are just clearance for a 080 screw, and then pre-ream size for these two holes. Then I have a boring operation to open these up because it means I can mess with the tool offsets to exactly 3/16 diameter. Not that it matters because I'll be making the pin that fits in here on the jig and the final pivot, but as long as they're both the exact same diameter, might as well. And I'm bringing in this end mill either way to do these counterbores. I believe this is just a 1/16 end mill, and then 2D contours to open up those counterbores. I'm not bothering to counterbore these holes or this shape here. My idea, and this might be completely incorrect, but this operation I'll be having it clamped down, and really I just want to get these locating holes down and get ready to put it onto the jig. So let's show the jig. So once all those holes are bored and ready to go, now I can put them onto a jig, and I'll start with the back side because at this point curved feature will not be added yet. So I can flip over these handles and screw down through the holes because these holes will be added. That's the only feature that will be added. It will just look like this orange, yellowish piece with holes in it. So I can just screw it down. I also added one hole here that will be drilled. Let me make sure I have that. I'm not sure if I do. Yeah, I do. So that hole just to be drilled through. This way I have what I would assume was happen. Once again, I haven't actually ran this code, so maybe the screw's not necessary, but with almost an 8-inch gap in between this screw and this screw, I thought this middle part might vibrate, so I wanted a screw in the middle to hold it down. So when I'm doing this backside, it will be held down with a screw here, and then two on each end. Then I'm going to go in. This is the stop pin. So these holes are not through the handle, they're just a little ways in. This is another feature that I'm adding that I haven't done on folding knives before because it's really difficult, purely because getting a flat bottomed hole in like a 1/16 hole is kind of difficult. I think I'll be able to do it here, or I have a thick enough material. This is 1/8, where my other folding knives have been 3/32 stock, so I have a little extra room to play in this hole. So here's drilling those. You can see it goes down, the tip hits the bottom of the hole, and then reaming them. So yeah, I won't have a ton of depth, but they're right next to each other, and they're inside that groove, so I don't think this will be a problem. And then a 2D contour to cut this little groove for the lock bar stabilizer. Now the back side, so that's the finish of the back side. Now I flip them back over and work on the front side. So now I'll be putting screws into these holes and holding it down. They will not have this curved surface. The stock will still look like this one, kind of yellowish box. We can do a full simulation of this. Go show stock, and we'll go through this a little more accurate because this is where almost everything happens. So here you go. Oh, geez, let's look at this a little bit better. Here we can see it cuts out that counter bore and then the triangle. Same with this side. This is just the counter bore. So if we hide and show stock, you can see it's just cutting out this bigger diameter, not this little inside diameter is already drilled out. That's why I have no problem plunging straight in. Okay. That's the first operation, and then a 2D contour to clean up those sides and the inside of that triangle. And then it's just a 2D contour with a ramping option set. Goes around each handle about 3/4 of the way down. So we'll go through that. Okay, so you can see it goes down about 3/4 of the thickness of the handles, leaving a decent amount of material here, but also clearance to come in and do the 3D shaping. Now I do another operation where I go down this side all the way through. So now you can see this side is cut all the way down to the jig, but is still held on the other 4 sides or so. Now we get to the long part using a 1/8 ball and mill, and I'm just doing a parallel toolpath over the top, just giving it that nice rounded shape I'm after. Obviously, the simulation isn't particularly accurate, but it's a pretty nice finish. The math says it's less than a 10 thou. I think it's actually considerably less. Let's look at that math real quick. So if you go inside the parallel toolpath and go over to, what is this, passes? Yeah. So we have the tolerance and then the step over. So I have a 10 thou step over, which means that that is still going to be, what is that, 4/10 crest height. What are these called? Cusp height. So that's tiny. It's a really good finish, basically. I might even change this to, I don't know, 20 thou. Let's look at that. It's going to take a little while to regenerate, but that now, if we just do a quick simulation of only that toolpath, it's now only taking 28 minutes. Not too bad. The feeds and speeds I've set are pretty close to the ones the machine will use. Let's go back to this. Very good. Okay. Now, the one other thing I have. Okay, yeah. So here I'll show you why I had cut through just this front side. So to do this fancy fillet, I do it in a different operation, and this operation goes way down to get this full radius all the way down to the edge. So I can't have any extra stock hanging down, because down at the bottom of this, let's look at this in an easier situation. You can see these toolpaths go all the way down to the jig, and so it won't work to have that little bit of material, because it ends up, the end mill just plunges in, which I don't want.
This is just the facing off. It's going to do a horizontal and a 2D contour after this to add the 2 locating pins, and then just spot drilling and tap drill size holes afterwards, and then it's done. So yeah, pretty simple. Looks like it's working well. I can barely hear it cutting. It sounds about the same as just the spindle on.
It's just finishing off the last operations here, drilling the 080 tap drill holes. Machine just turning off and pulling the table up to the door. As you can see, it turned out pretty well. All the holes are in the right place. The finish is decent. It looks kind of swirly, but it's really flat, so that's all that really matters. Here's my setup to drill the locating holes. It's just got those 2 bolts on either side. This isn't a great setup, but it works just fine for drilling the holes. It's on the back side of that jig I just made, so kind of repurposing the piece of aluminum. So once the locating holes are drilled, I mounted it back on the jig and did the backside holes. So this is just the stop pin holes and the detent ball, and then this 3D toolpath, which I'll explain in a second. There's the part I just took off, so you can see there's the 3D toolpath. That's the lock bar cutout, the what gives it the correct springiness. That's the kind of lock bar stabilizer slot. Stop pin holes, so they're reamed to 16th really accurately. I really like reamers, and that's about a 55 thousandth hole for the 1/16th detent ball to press into. So yeah, this is the titanium. It's about to have that done to it. There's also supposed to be my name here and the date. That didn't work because this is about 118 thou, and it's supposed to be 1/8 inch, so that's what, 7/8 thou off. This is about 5 thou over, so it should have the full engraving. We can see both finished, the titanium one on the left, the steel one on the right. You can see my name turned out well, the full engraving on the titanium one. Now I'm going to run the front side operations. Here's the steel one. Once I finish that, it's about an hour and a half operation with the 3D toolpath and everything. As you can see, it turned out pretty well, and I left a little bit of material so that the scrap didn't fall off and get jammed in the end mill or anything. Here's the titanium one. Same thing. It didn't cut quite the same. You can see that the tab got really thin in the middle. That's because the titanium bent up as I removed the material with the 3D operation. So here I am just cutting away the scrap and cutting off the tabs, and this took a while. Here you can see them after I hand filed a lot of the burrs and stuff off. They turned out well. They are bent up about 20 thou in the middle because of all the material I removed on the top, just the way some materials stresses are. I'm going to redesign the jig to hold them in a different way so that they don't bend up while it's being cut. So yeah, I'm going to come out with a video talking about that soon. If you guys enjoyed the video, please like, subscribe, and comment. Have a good day.